everyone. Welcome to Conf42 2025. My name is Vaibhav Fanindra Mahajan, and today I'll walk you through how Retrieval-Augmented Generation, also known as RAG, offers a huge improvement over conventional chatbots in the enterprise support domain, especially when it comes to accuracy, scalability, and knowledge integration. We'll first understand how traditional chatbots work. Traditional chatbots, even the more modern ones that use intent classification or basic NLP, rely on static knowledge and hard-coded flows or pre-trained models with limited ability to adapt. They are built using rule-based systems that scales poorly and can easily break on edge cases. They're trained on like a snapshot of data, which becomes absolute very quickly. And the session state management is often brittle or non existent, making multi turn context detection weak or absent. So, in other words, none of these scale in real world customer service environment where like data is continuously evolving and there are diverse user queries every day. As a result, this causes a maintenance overhead. You need to manually update knowledge bases continuously. And there is a risk of hallucination when the model doesn't know the answer but still guesses it. And the most critical one, like the system can't handle novel or low frequency queries because they're explicitly encoded in the training set or a dialog tree, which creates a feedback loop of high operational overhead and poor user trust. Here comes RAG in the picture, and RAG shifts the paradigm by introducing real-time document retrieval as the very first step to response generation in the chatbots. First step involves understanding the query the user has asked or using advanced transformers with semantic embeddings. Later, the query is embedded via BERT or sentence transformers, then matched against a vector store like FAISS or Pinecone or Vespa to retrieve the top K passages. And once those latest information is retrieved, this data is fed into the prompt for language model, enabling like a grounded generation. And in case if the data updates are detected in any of those while retrieving any of these data, the delta of those information gets indexed automatically and gets made and is then made available in the next retrieval cycle and saving the efforts on fine-tuning the models again and again. Along with that, like traditional bots typically fail at handling composite or like multi-intent queries due to linear dialog flows and like limited memory as well. RAG in these situation introduces multi-stage reasoning. So the way it works is like the complex inputs are passed into smaller structured sub-questions into using semantic and segmentations. And then each component is independently and individually queried against the vector store. The system then can pull from multiple domains or knowledge clusters. And then the retrieve snippets are fused using either concatenation or specialized summarization layer, fusion in decoder. Then the language model generates a comprehensive unified answer that covers all parts of the inputs, something like which is very difficult to achieve with a traditional bot. Later, due to all these applications, RAG is able to achieve a higher accuracy over traditional chatbots and LLM models because of its ability to ground responses with real data. The language model is conditioned on retrieved documents, so the outputs are based on actual enterprise knowledge and not the parametric memory or like the stale memory which is out of date. And in these situation, if let's say the relevant documents for some outage or downtime aren't retrieved, the system can return fallback messages or uncertainty signals instead of guessing, improving the trust and transparency. Along with that, RAG systems can estimate confidence based on retrieval scores and response entropy, enabling you to set thresholds and escalate uncertain responses or ask clarifying questions in situations when the model is not able to, or if the estimated confidence level is below the set threshold. Apart from like the accuracy aspect of the RAG-based system, the other very big benefit that RAG-based chatbot brings in improving the user experience that it can be augmented with session level memory with using embeddings or key value stores. So basically what it can do is then it can track user intent, slot fills, and previous interactions to maintain context, even across like multi-turn conversations. This in turn results in automatically more coherent dialogue flows and like higher task completion rates, hence elevating the user's experience. Apart from this, in a domain of customer support, even like the advanced automation, there will be a point when some conversation needs escalations. And in this situation, having an AI agent that is able to store context and intent, in those situations, the handoff to human agents helps in bringing the human agent up to the speed of the issue very quickly because the RAG-based system has all the context and intents already stored in its database. So with RAG, we can achieve like a structured handoff to the human agents through delivering a package with query history, retrieved documents, and generated responses. An agent no longer needs to ask questions again and again or dig for background. They get full context, including the intent chain and prior decision points, so that they are already up to the speed with the customer's issue. This in turn reduces average handling time of a customer and improves both agent satisfaction and first time resolution rates. From a design view, these all can be easily integrated with any of the CRM applications that any organization is using for the support operations in their company. And so in order to make sure your RAG-based bot is up to date with all the knowledge and all the latest information, and this is all because like in a live system, document in the knowledge base are bound to change. So in order to make sure your RAG-based chatbot is always up to the date, we need to establish a continuous knowledge update pipelines. So as soon as like content like policy document or support articles is updated, in the source systems like Confluence or any of the CMS system that the company is using, it needs to get ingested and queued for reprocessing. And once that happens, a background job should vectorize these content using embedding models like BGE, MiniLM, etc., and then update the semantic index in a vector database like FAISS or any of the corresponding data vector databases. Later, so what this does is like later, whenever a user query comes in, the retriever immediately surfaces the latest relevant content, ensuring the response reflects the current state without any model fine tuning. And the generator model conditions its output on the updated context, enabling it to answer questions about the new feature policy or any of the policy changes or known issue on the same day the document was changed. So the response will always be with respect to the latest updated data. So all this is works fine in the ideal world, but in order to have like a performant or like a well-running RAG-based chatbot, we need to have quality data knowledge base. Because RAG's performance, I would say, is directly tied to the quality of the knowledge base you have. So, in other words, this is a situation of where like you put in garbage and you will get a garbage out. So, in order to make sure like that doesn't happen, we need to make sure all the redundant data or near duplicate documents or contents are removed from the content base. And other ways we can do is like normalizing conflicting entries that can in some way confuse the retrieval mechanism as well as the LLM models in generating response. There should be a structured KB using clear topical taxonomy with fallback links in situation if the content is not available. Along with that, like there should be metadata tagging for all the content so that it's easily available for filtering and at the time of retrieval. So uh, this is like a high level information about like the technology stacks involved in each layer of RAG based chatbot. For knowledge base, there should be proper document vectorization and metadata tagging for easy retrieval. The retrieval systems should be equipped with vector databases and semantic search for the models to easily select. Then the language model can be any of the LLMs that are out there in the market for actually generating the responses. And the last piece is the security, which is the most crucial one, because even after the retrievals, there should be one layer of access controls and query filtering that should be in place to make sure there is no data breach and unauthorized data does not get sent or gets displayed to the customers. So now coming to the future avenues of ad-based chatbots, since it's context awareness and working with real-time data, it has opened door to a very hyper-personalized and behavior-aware support experience. Customers, there can be customer-specific retrieval, basically segmenting vector indexes per customer profile or organization. Along with that, it can also detect anomalies in usage logs and these logs can be readily made available to these chatbots so that it can predict some sort of outage and then proactively surface help. This is one of the use cases we are currently working on, and our goal is to achieve a state where we detect an outage even before it happens. Along with that, since the models are connected with live data, even if let's say a bot has been trained or has been embedded with one language, since it can always retrieve new information, it is possible to have the bot respond in any other language as per the user's need, which makes it perfect for an organization which has a global presence and has customer base spread across the globe. And along with this, the next evolution in multimodal RAG, where inputs and retrieve content are just not limited to text. Some of the emerging capabilities currently we have is the visual search and retrieval. Basically, customer uploads an image and then the RAG models tries to find a match against the corresponding visual KBs, example, like a photo of damaged product, or error screenshot that the customer just uploaded, and based on that it is able to troubleshoot, and based on that the chatbot is able to troubleshoot what the customer issue is. Apart from that, retrieving instructional videos based on any text that customer provided so that it can provide more helpful information or resources to the customer to solve their issues. And later it could be like a fusion of both text and video and vice versa that can be implemented with the RAG based chatbots. Architecturally and technically, these for us to enable these features, we need to have some sort of vision encoders. For example, I think Clip and Flip2 are some of the widely used coders that are out there in the market, and some sort of cross-model retrievers, which will for sure help in expanding the use cases for RAG beyond text. Now, here are some stats that we collected that shows a tangible improvement in customer support operations across multiple KPIs. These have directly impacted operational efficiency and customer satisfaction. These efficiency gains stem primarily from improved post-contract resolution, as you can see, has a number of around 75 to 85% compared to 45 to 55. And also the reduced need of clarification exchange is another thing that has proven that the RAG-based model has been tremendously very helpful in enhancing the user's experience while trying to find support. To wrap up, the evolution for traditional AI chatbots to RAG-powered system represents a transformative advancement in the customer support technology, since it enables like grounded real-time answer that scales with knowledge changes. So the customers are always given like the latest information. It reduces the retraining cycles and lowers the operational overhead, which saves any enterprise organizations a lot of money. Context continuity even across long interaction so that us don't get irritated in explaining the same things again and again. And the use cases are still like, since it's an evolving technology, there are many more room for more evolution in this domain. So thank you so much everyone for your time. I'll be happy to answer any question regarding RAD and how it can be used to improve customer support operations. Thank you.